Hi everyone, welcome back to my channel. If you're new here, my name is Stefan, and today we're going to do a deep dive into a topic that a lot of you have been wanting me to discuss, which is HAARP. HAARP stands for High Frequency Active Auroral Research Project, and I was led to investigate HAARP further when I saw this highly anomalous power burst in the Schumann resonances recently, thinking it might be an earthquake precursor. That still may be the case, but that led me to investigate the HAARP rabbit hole. It's interesting because in real life, I also recently found a rabbit hole in the garden. There's 4 cute little rabbits there. I think they might have been abandoned by their mom, so I might have to care for them. But what I discovered is that rabbit holes don't actually go that deep. And it is the same for HAARP. The research is out there. So in this video, I'm going to break down the connection between the Schumann resonances, earthquakes, radiation belts, the ionosphere, and HAARP. So I suggest that you cozy up, grab a cup of joe, and let's go. So in my last few videos, I've been talking about the geomagnetic storms that have been happening on our planet, and the sun has recently been very active. So I want to show you the solar activity right now, as well as the near-Earth electron flux, X-ray flux, and proton flux as measured by the GOES satellite at 5.6 Earth radii away in the radiation belts. So you can see here the sun, huge X-ray flare right there, flashes off, and then we have a few more little bursts from the same region. That is roughly where that coronal hole was that gave us the largest geomagnetic storm that we've had in the past 6 years. And you can see that electron flux went up and up and up, and you'll see also why this is relevant to our conversation about HAARP later. So solar flares and solar activity can increase the density of relativistic electrons in the radiation belts, and then things like X-ray flux and proton flux can modify that further. We start this discussion though on HAARP and earthquakes and everything with this power burst here in the Schumann resonances. This is highly anomalous for a few reasons. This might look like any other power burst if you follow this stuff, but it is quite a bit different because it has an amplitude inversion. So if we look here, we see that there's very strong activity at mode 4, 25 Hertz, a little bit less activity at mode 3, mode 2 and mode 1 kind of blend together. But if we look at the amplitudes, then we can see that it's mode 4 that went to 61, mode 3 that went to 34, mode 2 that went to 23, and mode 1 that went to 25. So mode 1 and mode 2 are about the same, but it's mode 4 and 3 which are dramatically stronger when normally it's the opposite. A solar flare caused Schumann resonance burst will typically be, let's say, 50 for mode 1 and 35 for mode 2 and 20 for mode 3 and 15 for mode 4. But here we have the opposite. Now, if you don't know what the Schumann resonances are, they are frequencies of light that form resonant standing waves in the Earth. They have frequencies of about 7.8 Hertz, 14, 20, 25, 33, 39, and 45 plus Hertz. They're basically observable everywhere. If you stick some probes in the ground, you'll see them. You can measure them in the atmosphere. That's where they're very strong. They're also measurable in the ionosphere and even out beyond into the magnetosphere. Now, there's different components to the Schumann resonances because these are electromagnetic waves. So there are the magnetic components and then there's the electric components. And with the Earth's overall electromagnetic field, the magnetic components are horizontal. There's a east-west horizontal and a north-south horizontal, and then there is a vertical electric field. The magnetic components are picotesla in strength, and the electrical is millivolt to microvolt in strength depending on where you measure it. Now, just a quick note is that the Schumann resonances have the same strength and frequencies as electromagnetic activity of the human brain. So if they are able to enter into resonance with each other, then there is an ability for energy and information transfer between these natural global geophysical energy layers and your own biologic system. What's been noted with the Schumann resonances is that they connect to almost everything. These frequencies of light here, going from 0 to 40 Hertz, and we have our time axis below, here's our power legend. These frequencies of light are connected with the ionosphere, they're connected with the temperature of the atmosphere and overall climate fluctuations. They are created primarily from lightning strikes, so there are other things that feed the Schumann resonances too. They are connected to telluric currents under the ground and earthquakes because you see anomalous Schumann resonance signals like this one before significant earthquakes. This actually may be a pre-earthquake signal, and we will talk about the connection between the Schumann resonances and earthquakes, I think on the next slide, but in just a few slides. So they are connected to almost everything. There's a lot of evidence that they're connected to human consciousness, and that these Schumann resonances connect all of humanity together. And with the recent research I did into HAARP, there is clear evidence that HAARP is able to alter the Schumann resonances. So yeah, there's a big connection here, and we're going to dive into all this in this video as best as possible. I want to lay this out, so I suggest you watch the entire video to get the comprehensive picture. Now, if we look at our recent space weather environment over the past like 6 days, going to the 29th, we see this geomagnetic storm there. The magnetic field of the interplanetary magnetic field went way up in strength. The vertical component went down. So then we have this big volatility in the Earth's magnetic field. And what happens during something like that is the outer electron belt, which is around from, let's say, 3 to 4 Earth radii away. That's the 3 to 4 L shell going out to about 10. That gets depressed in terms of its electron density. You can see that here when that storm came in. The data before was right at that alert threshold. It then got dropped down. These are mega electron volt electrons as measured by the GOES satellite. It got depressed down during the geomagnetic storm, and then it started to rise afterwards, and that is what is normally seen. What's normally seen is that these highly energetic electrons, these relativistic electrons, get depressed during a geomagnetic storm, and then during the recovery they go up, return to baseline, or even become enhanced. So we saw that effect with this geomagnetic storm on the 23rd, the 24th, the Plutonian geomagnetic storm, strongest in 6 years. And then we started to see things like this. We started to see strong activations in mode 3 and mode 4, those frequencies that are linked to earthquakes. Anomalous like 10 to 12 hertz activity in between modes 1 and 2 of the Schumann resonances. Small little vertical spikes there. You can see, you know, some power bursts at like mode 3 there, and then this real big, wow, what is that power burst in the Schumann resonances that has that amplitude inversion. Again, mode 4, 61. I've never seen mode 4 go anywhere near 61 before, which led me to think, okay, is there an earthquake on the way, or was this artificially induced? So if we look at the frequency, we see that mode 1 had a big drop in frequency. That is to be expected because when power goes up, frequency goes down. Mode 2 didn't really budge too much, but what's interesting here is that mode 3 and mode 4 actually went up in frequency during this power burst. So that is also anomalous and hard to explain. Huge increase in the qualities for mode 4 and 3, and the qualities are effectively a measure of how much energy is in a system and how much energy is leaving that system. So you can have a huge pool of energy, and if it is just having a small amount pool away, then you have a high quality. Likewise, you can have a small pool of energy, a small potential energy, but if it's just the smallest trickle, then the qualities are also still high. So this is effectively a measure of like the overall potential of a field, like what is its energy storage, and then how much of that energy is leaking out. And when the qualities are up, that's a sign that there is a lot of energy in a system and not much movement leaving it. And then when the qualities go back down, that means that there's been some release of energy. So we see that during this power burst, we had a huge increase in the amplitude, and we also had a huge increase in the qualities. So what that is kind of telling you is that there is now much more energy stored in mode 4, and that some of this energy also moved within the Earth system. Okay, so let's talk about the connection between earthquakes and 20 to 30 hertz electromagnetic precursor signals. There seems to be a strong connection between very powerful land earthquakes and energy in the 20 to 30 hertz range. And there's a few potential reasons why they're probably both true. If we look at this map here, they did a look at earthquakes greater than magnitude 5 from the course of 1999 to 2004. And they started to do this research because of this very anomalous increase in 20 to 30 hertz noise that was noticed at the time of the Kiki earthquake in Taiwan, 1999. That was a very strong earthquake, and we saw this huge burst in intensity for those frequencies as compared to normal. So they did a comprehensive review for all the earthquakes during this 6-year time period, and they saw that all the land-based earthquakes had anomalous increases from 20 to 30 hertz, and the 2 sea earthquakes that also had anomalous increases in that frequency range were A, the largest, which is a magnitude 7 there, and then also the shallowest, which they put it at 0 kilometers. The epicenter was probably not 0, but it was clearly the shallowest. So that goes to tell you that when there are earthquakes on land, it has a greater ability to facilitate this release of electromagnetic energy. And if it is to be observed by a sea earthquake, it has to either be very, very powerful or very, very shallow, because electromagnetic waves attenuate as they travel through mediums, unless it's a vacuum. So ocean water, being highly conductive, absorbs all this energy very well. Hard rock also absorbs it. The deeper the earthquake, the more it's going to attenuate out, and the higher the frequency, the more it's going to attenuate out. So that's why we are seeing these extremely low frequency waves and not higher frequency waves. Now, they have seen at times higher frequency waves with earthquakes, but it seems that overall the most common earthquake precursor signal are waves in that 20 to 30 hertz range. And the reason why these might stand out more than background is because the mode 3 and mode 4 of the Schumann resonances at 20 hertz, 25 hertz, mode 5 at 33 hertz, those are generally much, much weaker than modes 1 and 2. So they're going to stand out more when they have an elevation in signal. Here we can see some examples of this. We have a regular spectra, and then we have an anomalous spectra. This is around the time of an earthquake, and you can see here where everything's basically nice and normal, but then during the anomalous time, the red is like the monthly average. You can see the blue shoots up by quite a big difference there. This is amplitude in nanoteslas. So you can see that it goes up and adds at least a nanotesla on top as compared to the median, like normal value, the average power spectrum. So that is a sign. If you see that, while there is no earthquake activity, that could be a sign that an earthquake is on the way. One condition of all this is how close is your observation station to the area of eventual epicenter. That matters. If you want to look at an actual spectrogram, you can see here, this is the Kiki earthquake, and that was on September 21st, 1999. And you can see there were some pre-earthquake signals there. That's this guy right there. So big burst at 25 hertz. And then there was even some stuff that was released afterwards. So this spectrum there looks pretty similar to this in some ways. This is a different monitoring station, different color setup and everything. But yeah, that is what a pre-earthquake signal looks like. Now, one of the ideas for this is that these pre-earthquake signals are as a result of electric currents in the earth, the circuits closing. That movement of electric charge, that electric current, creates a magnetic field. And if it has time-varying properties, then that is a fluctuating magnetic field which can have a frequency like 25 hertz. And so therefore, these waves, because the currents are so strong, like millions of amperes in strength, these waves emanate out. A lot of them attenuate into the crust. They're probably generated at all frequencies, or at least a wide range of frequencies, but it's only the lower frequency ones that are able to get through 10 or 20 kilometers of crust, hard, dense rock, and reach the surface and then propagate out and be observable over baseline noise. So that is one reason or idea as to why earthquakes are connected to 20 to 30 hertz electromagnetic waves. That makes a lot of sense to me. There's also the idea that it's changes in the ionosphere altering the Schumann resonances that are already resonating in the atmosphere, and these ionospheric disturbances over an earthquake epicenter deflect and change in overall disturb the properties of the Schumann resonances, which are then measured either near the earthquake epicenter or close by. So you can see here, this is like a regular ionospheric profile, and then there's a disturbed profile, and you can see the conductivity changes. So at a certain height above the surface, we go here, let's say we go to 30, well, let's go to 50 because that's the ionosphere at that point. If you go to 50, regular profile is going to have a conductivity of like negative 9.5. But then for the disturbed profile, it's all the way over here at like negative 7. So it's much more conductive. So that's a sign right there that there might be something happening if you notice a ionospheric shift in conductivity. And that is what HAARP does, is it changes the conductivity of the ionosphere. So we'll get into all that. Here's a simplified graphic showing that, let's say there's earthquake epicenter here. It then changes the structure of the ionosphere, can lower it, alter its electric fields of potential. And then when the Schumann resonances are going like this and they interact with this new region, they alter in their resonant characteristics because their resonant frequencies are determined by the waveguide characteristics. So the surface of the Earth doesn't change all that rapidly, but the ionosphere certainly does. Now, the main precursor effects for an earthquake are that the ionospheric height and conductivity changes. So the ionosphere goes lower and the conductivity typically goes up. And that is often seen before large magnitude land earthquakes. There are massive telluric currents in the crust due to lithospheric stress, and these create electromagnetic waves. They're potentially what causes the actual slip to occur by breaking atomic structures down. And only the lowest frequency of these waves reach the surface before they would have attenuated out. Energy in the 20 to 30 hertz range sometimes has anomalous power increases preceding an earthquake, and the stronger the earthquake, the further in advance these earthquake precursor signals may occur. And we saw these before the magnitude 7.8 earthquake in Turkey on the 6th of February of 2023. I covered that in prior videos if you want to watch those. Now, significant frequency deviations from the norm can also occur for the Schumann resonances at those frequencies. Mode 4 at 25 hertz, mode 3 at 20 hertz. It might be a frequency drop. That's more common because amplitude, again, if power goes up, frequency goes down. But it's just in general deviations from that pretty tight range that the Schumann resonances occupy is potentially a precursor signal for an earthquake. So what is HAARP? HAARP stands for High Frequency Active Auroral Research Program, and this is relevant to our discussion on the Schumann resonances in the ionosphere because HAARP directly interacts with the ionosphere. HAARP is a type of ionospheric heating, and there's actually other programs that do this, other countries. So HAARP is the strongest that we know of, and it has the largest frequency range that it can use there. Here's its effective radiated power. It has a total power of 3.6 megawatts. And then Norway has some different ionospheric heaters. Russia does too. There's another one by Norway. But HAARP is the strongest by far. And this is well, here's what it looks like. You can see all these dipole antennas that they have set up in Alaska. And these basically just beam up high frequency radiation and high energy radiation up to the ionosphere. If we look at our graphic here, we can get a sense of what that looks like. So here is the emitter, and it is sending this wave up and creates this ionospheric disturbance. And then these waves are injected into the magnetosphere, and well, the ionosphere and the magnetosphere, because they follow the magnetic field lines, and then electrons from the ionosphere and the electron belts way out here are then able to move down those field lines because they get agitated by these waves. And then this is all picked up on the other side of the world. And you also get some of these reflections here too, but they heat up this part of the ionosphere, changes conductivity, they can even lower the height of the ionosphere. HAARP is like a flashlight and not like a laser. So it heats up a pretty wide region, and then these injected waves travel along magnetic field lines, various effects that happen, but they cause electrons, these highly energetic electrons that are stored in the radiation belts to then begin moving down the field lines, whereas normally their rate of flux is pretty low. So HAARP can have a significant effect on the energetic qualities of the radiation belts, where a tremendous amount of energy is stored. So HAARP and other ionospheric heating systems have the ability to modulate geophysical energy layers from the lithosphere to the Earth's radiation belts. HAARP heats the ionosphere with megawatt radiation similar in frequency to the natural frequencies of the ionosphere. It uses that megahertz range, which is what the ionosphere typically, it's resonating in that megahertz range. And HAARP goes all the way from 3 to 10, as you can see there. Heating of electrons in the ionosphere reduces the electron-ion recombination rate. So electrons and ions, there's positive ions, they are looking for an electron. And the reason why they aren't necessarily connected is because it's too energetic in the ionosphere. There's too much solar radiation that's breaking these bonds apart all the time. X-ray flux is going up. You have extreme ultraviolet light hitting the ionosphere and breaking up these bonds, but they want to reconnect. HAARP disrupts and reduces that recombination rate, and it locally increases the plasma density as a result, therefore increasing the conductivity in the area that was heated, that wide zone. These HAARP injected waves continue to travel along the magnetic field lines out beyond the ionosphere and into the radiation belts. And they can even then travel all the way to the other side of the planet, depending on which field line is targeted, depending on the angle and everything like that. Now, Earth's radiation belts are home to extremely energetic relativistic ions and electrons. This is basically ions and electrons that are traveling near the speed of light, 85% of the speed of light or more. So that's the term relativistic. And their natural energy diffusion is relatively weak. For example, back here, when you have a geomagnetic storm that raises the relativistic ion concentrations in the electron belts after the storm, it takes weeks for them to decay sometimes. It can be a long time, whereas lower energy electrons will decay within a day or two. HAARP is able to increase the diffusion of these relativistic electrons, and actually it can be the dominant precipitation process for the area that it is targeting, and each one of these energetic electrons is capable of breaking many thousands of molecular bonds. So when it starts to rain and precipitate down into the ionosphere, it can break apart a lot of molecular bonds that have reestablished in the ionosphere. It can, if it goes even below the ionosphere, it can break up ozone or different chemicals. And let's say one of those electrons was to go all the way to the surface, it would create quite a bit of damage at the molecular scale because of how much energy it contains. Earth's magnetic field lines connect different locations on the planet together, and electron precipitation occurs along the same vectors employed by HAARP. Again, you can see that clearly right there, the electrons precipitating down while the injected waves go up along the same line. Experiments have clearly demonstrated that artificial heating of the ionosphere can excite relatively large amplitude electromagnetic waves at the Schumann resonances and nearby frequencies when the ionosphere's F layer is strong and certain HAARP frequencies are employed. They can use a single frequency, they use a band of frequencies. They've done a whole bunch of experiments here. They've even now sent HAARP signals to Jupiter in hopes of getting information back from Jupiter's ionosphere and Jupiter's magnetic field. So HAARP is pretty significant. So I want to compare the relative energies of HAARP to other things and go on a little bit of a tangent to kind of put this all in context for you. We have to understand what the strength of HAARP is to get a sense of whether it could be used as a geophysical weapon, which is what a lot of people think HAARP is. People think HAARP is a geophysical weapon. Some people think that HAARP was used to induce that magnitude 7.8 earthquake in Turkey. So yeah, a lot of controversy surrounding HAARP. Now, a lightning strike on average measures 300 million volts and 30,000 amps, which equals 9 million megawatts. So that's a single lightning strike, and there's about 100 lightning strikes on the planet on average. For reference, a microwave's power, the one that you would use to heat your food, is about 1,000 watts in strength typically. Now, volt is a measure of electric potential. This is the velocity of an ion or electron, something like that. Amperage is the electric current. It's a measure of electric current. So the quantity of electrons based on time. And watt is the rate of power flow. So this is like radiant flux. How much electric potential and what's the quantity of electrons that are moving this electric potential. So you can see here that 1 watt equals the volts times the amps. Now, HAARP runs at 3.6 megawatts. So this is 3,600,000 watts. You might have heard of the Russian woodpecker. This is the Duga radar from the SSSR, the USSR. This is outside north of Kyiv. I've actually been there. That ran at 10 megawatts, and that was operational back in the 60s and 70s and 80s. And you can see how large it is there. HAARP is also a very large facility. And I want to make note of that because during the collapse of the Soviet Union, they actually had to abandon a lot of their products, and they had a fully functioning space shuttle program that they just completely abandoned when it collapsed. And they also abandoned these radars too. What that goes to tell you is that it's not like Russia completely disintegrated into a whole bunch of autonomous states. Like, they still retain themselves as a country, though they lost their, expanded territories. So the fact that they're willing to give up their fully working space shuttle program that they had put a lot of time and energy into shows you that they had money going elsewhere that was more important than this. They had other projects that are more important than this. And back then, this was pretty important. This is a pretty big deal right here. I actually visited the Duga radar, the woodpecker, back in 2021. You can see some footage of it that I took here. It's a really colossal Goliath thing, and it's in the Chernobyl exclusion zone. The reason why it's in Chernobyl is because that's where the nuclear power plant is, and running at 10 megawatts requires basically a nuclear power plant if you want continuous runtime. So they put this just right next to the power plant so they could run this thing, and they were using this for a variety of reasons. They were using it so they could track the movement of intercontinental ballistic missiles, but there's also some evidence that they were potentially trying to alter brainwaves and things of that nature with this, or at least just cause a gunking up of electromagnetic noise on the East Coast and West Coast of the United States. So you can see here, that's me for scale. These are massive, massive antenna there. And it was really an eye-opening experience going to Chernobyl in Ukraine, because it let me kind of realize that there's a lot more going on than you realize. And the fact that they were willing to give up this space shuttle program, like, what else were they doing that that money went to? Because to give that up is pretty significant. Same with the Duga radar. Now, HAARP runs at 3.6 megawatts. This ran at 10 megawatts, but you'll see why I'm mentioning this in just a little bit. Okay, so HAARP, electrons, Schumann resonances, and earthquakes, how are they all connected? Well, they did studies with HAARP, and they were actually able to incite waves at Schumann resonances. So there, they did a test where they modulated their megahertz pulse with HAARP at an 8 hertz wave. So 8 times a second they were turning it on and off, and lo and behold, it basically activated the 8 hertz Schumann resonance and bumped it way up in terms of its spectral density. So you can see there, went up from less than 0.5 all the way up to like 2 or so. And then they did this at 7.6 hertz, same thing. 7.6, you can see the frequencies that they use there, the actual frequency of that like flashlight beam. But this is just going to show you that HAARP has successfully altered the Schumann resonances on certain time scales. Now, the central frequencies of resonances are defined by Earth's waveguide parameters, namely the height that the ionosphere begins at, which is the D layer during the day or the E layer at night, and also the conductivity of these layers. The energetic properties of the ionosphere are mostly determined by the sun's output of ionizing radiation and energetic particles like electrons and protons and heavier ions. And this is all done through things like solar wind and solar flares. So it's mostly the sun that influences the ionosphere. You can also have radiation coming up though from below the ionosphere, natural or artificial, and HAARP is of course artificial. By changing the plasma density and conductivity in the ionosphere, HAARP is able to generate magnetic field-aligned currents / Scheer-Alfvén waves. And there is a high degree of conductivity coupling in the ionosphere. So if they are targeting the F region, for example, that is also likely mirrored in the lower E and D regions, which means that there are now ionospheric height changes that would influence the Schumann resonances. Artificial ionospheric heating has repeatedly and conclusively shown to be able to significantly alter the properties of the ionosphere, cause large amounts of significant electron precipitation from the radiation belts, these extremely energetic layers that you can see here, and alter the Schumann resonances. All of these, of course, are greatly interconnected to each other energetically, in addition to the lithosphere and earthquakes. I mean, you can see here with the Earth's magnetic field, it comes out of the core through the Earth and then goes into space. So if you're playing with any of these systems, fundamentally you're playing with the other ones. The question is, to what degree? Is it significant or is it basically insignificant? And we saw this power burst here in the Schumann resonances with highly anomalous characteristics. Mode 4 going to the amplitude of 60 is very bizarre. I don't know what to make of that. It could be natural in origin. It's really difficult to say, but there was no real strong solar factor at play during that time. We saw the data for that. There was nothing that was really out of the ordinary. So unless this is a pre-earthquake signal, which it very well could be, there could be a large magnitude earthquake inbound any moment now, then it leaves some questions as to, was this induced artificially perhaps by changing the properties of the ionosphere? One thing to keep in mind is that in 2015, HAARP was actually given over to the University of Washington. So this was run by the Air Force before that, and then they handed it over to the university to conduct their research experiments. I'm a little skeptical that they would just hand this over if they didn't have something better to use that was more of like a clandestine operation. So think of that what you will, but this is a 3.6 megawatt facility. They've been using it since the 1990s. That's actually when they first noticed impacts on the Schumann resonances. So it's right away in like the 90s. And when they handed it over, it makes me think that the Air Force or these other groups have something better that they're using, something stronger that they're using now. And maybe they're just not talking about it. It's classified. It's hard to say. We're trying to sort through the shrouds and everything and find the truth here. But the truth is that the Schumann resonances are interconnected to the ionosphere and the lithosphere and earthquakes, and that HAARP is able to alter the ionosphere. It's able to alter the Schumann resonances. It's able to alter the radiation belts. And since those are all connected, if you're playing with a toy that you don't understand, who knows what happens? This is a kind of a visualization, just to wrap things up. This is a visualization of what HAARP is effectively doing. But this is natural. Lightning strikes will create these waves naturally, and they sweep electrons and other ions out of the radiation belts in this L slot zone, which is around 2.5 Earth radii away. This is because of the natural frequencies travel at that distance. And so these electrons precipitate out and you form this typically two-band radiation belt structure. This is a natural process there. Let me pause at that nice point. What HAARP is doing is effectively the same, except HAARP has the ability to modulate its frequency, or just in general, ionospheric heating has the ability to modulate its frequency and its power. So while 3.6 megawatts is quite a bit weaker than 9 million megawatts, which is a lightning strike, we don't know what the strength, we really don't know what the top strength is for a ionospheric heater, an artificial one that may exist on this planet. And it's all about unlocking fields of potential. There are huge fields of potential on this planet. These electron belts that you see here are incredibly strong in their potentials because they have these ions and electrons moving around at nearly the speed of light. So the idea behind a geophysical weapon is that you just need to trigger that field of potential to then release. And if it does, the effects can be devastating. So I know I maybe didn't answer your questions on whether I think HAARP was used to trigger earthquakes or whether it is a geophysical weapon or things of that nature. That's not the point of this video. The point of this video is to give you the information behind HAARP, behind these energetic layers, the Schumann resonances, earthquakes, and give you all the connections so you can make those determinations for yourself. I suggest that you do more research into this if you're interested. It's a deep rabbit hole, but at the same time, it's not that hard to find this information. It's readily out there. It's the stuff that I don't know that I'm more concerned about, and that's what I'm really starting to research into. So if you'd like to learn more about this topic and see those videos as they come out, because yes, I am doing a lot of digging into this, a lot of research into the Earth's natural energetic systems and how this connects to our consciousness. The Schumann resonances are connected to human consciousness. Then I suggest that you subscribe to my channel. If you like the video, please click that like button. If you'd like to support my channel, buy me a cup of joe, then you can support via PayPal. There's a donation link in the video description, or better yet, you can sign up to the Wild Free Forum, which requires a one-time minimum $1 donation, where you can talk about this free of censorship with other people in the Wild Free Forum community. So I hope you enjoyed this video. There's some other videos here on screen you may find interesting. Give those a watch and have a great day. Ciao.